Good day and welcome to today's class. In today's class, we'll be looking at what? Proofs on convergent sequence. Proofs on what? Convergent sequence. I'll be taking the following question and I'll be proving whether they actually converge or not. The first one, prove that the sequence n plus 1 over n converges to 1. What's the implication of this statement? It means that we should show that what? The limit as n tends to infinity of n plus 1 over n is 1. That's what they want us to show. You remember in the last video where we defined the limits of a sequence, or we gave definition for for sequence convergence. Let's recall the definition. We said that what? A sequence an converges to A if for every epsilon greater than 0, there exists a k belonging to the set of natural numbers such that what? The absolute value of an minus a is less than epsilon for all n greater than or equal to k. So in line with this definition, the first thing we are going to do is to try to identify our k. Try to identify k, element of natural number. That implies that our k is greater than 0. To identify our k, we begin from an minus a is less than epsilon. And what's our sequence an? That means what? N plus 1 over n minus what is our a? The supposed limit, or the real number which it converges to, minus 1 is less than epsilon. This implies that what? N plus 1 minus n over n is less than epsilon. This implies that 1 over n is less than epsilon. But recall that our n is greater than or equal to k, and our k belongs to what? Set of natural numbers. Therefore, our n is greater than 0, just as our k is greater than 0. If that is true, then we can take away the absolute value. We have 1 over n to be less than epsilon. If 1 over n is less than epsilon, it implies that 1 is less than n into epsilon, and that implies that what? Our n is greater than 1 over epsilon. If n is greater than 1 over epsilon, then it also implies that our k will also be what? Greater or equals to, our k will be greater than 1 over epsilon, since what? N is greater than or equal to k. So we take our k to be 1 over epsilon. Now we want to prove. What do we want to prove? We want to prove that what? The absolute value of an minus a is less than epsilon for every epsilon greater than 0. We want to prove that for every epsilon greater than 0. So we continue and rub up this definition. We say let epsilon greater than 0. Remember, those are one of the conditions in the definition. Let epsilon greater than 0 and let k element of the set of natural numbers such that k is greater than 1 over epsilon. We got that from there. Therefore, an minus a will become what? N plus 1 over n minus 1. And that becomes what? N plus 1 minus n over n, which becomes what? 1 over n. 1 over n. If that is the case, now for all n, greater than k, for all n greater than or equals to k, remember our k belongs to the set of natural numbers. Therefore, k is greater than 0. And if n is greater than or equal to k, it means that our n also is greater than 0. Therefore, we can do away with the absolute value. We have what? 1 over n. We have 1 over n. And since n is greater than 0, k is greater than 0, this becomes what? Our an minus a, which is what? N plus 1 over n minus 1 will be less than what? 1 over 1 over epsilon, which is our k. We got that from here. And by the time we take the reciprocal of that, it means that what? N plus 1 over n minus 1 is less than epsilon. And so we can say that the limit as n tends to infinity of the sequence n plus 1 over n is equal to 1, which further implies that what? The sequence n plus 1 over n converges to 1, and that is proved or proven. We can also take another sequence and we see whether it converges or not. Let's look at another one. Prove that the sequence, you can pause the video at this point and try to see if you can actually prove it the way we have done. If not, you can look at it one more time and see that you are able to prove that the sequence n plus 1 over n converges to 1. Let's say prove that the sequence, okay, prove that the limit as n tends to infinity of 1 over root n is equal to 0. When we see a question like that, it's still saying the same thing. It wants us to show that the sequence 1 over root n converges to 0. So in order to show that, first thing we need to do is to recall our definition of convergence. And what does it say? A sequence AN is said to be convergent is a sequence AN converges to A. Let's write it this way. A sequence AN converges to A if for every epsilon greater than 0, there exists a K contained in the set of natural numbers such that the absolute value of AN minus A is less than epsilon for all n greater than or equal to K. That's the definition which we have reminded ourselves. Now again, the first thing we have to do is to try to identify what is our K such that this will work. We want to identify K. In order to identify K, we start from AN minus A less than epsilon. And that is what? 1 over root n minus 0 less than epsilon. If you have any question, you can leave it in the comment section and it will be attended to. And so if that is the case, the absolute value of 1 over root n will be less than epsilon. But remember that our K belongs to the set of natural number and our n is greater than or equal to K. So if K is greater than 0, then n also will be greater than 0. And if n is greater than 0, root n likewise will be greater than 0. So we can do away with the absolute value. This gives us 1 over root n to be less than epsilon. If 1 over root n is less than epsilon, it implies that 1 is less than epsilon times root n. That tells us that 1 over epsilon is less than root n. Squaring both sides, I have 1 over epsilon squared rather, to be less than n. Therefore, our n is greater than what? 1 over epsilon squared. But remember, we said that our n is greater than or equal to K. Further implies that our K also is greater than 1 over epsilon squared. Then we can go ahead to prove. Now proving, we want to show that AN minus A is less than epsilon. So we begin from our AN minus A, and that is what? 1 over root n minus 0. And that gives us the absolute value of 1 over root n. Again, if that is the case, it means that what? Remember, our definition says what? For every epsilon greater than 0. For every epsilon greater than 0. Therefore, we are taking epsilon to be greater than 0, and let k such that it belongs to the set of natural numbers such that our k is greater than 1 over epsilon squared. So if that is the case, for all n now greater than or equal to k, the absolute value of a minus a subscript n minus a will be equal to 1 over root n absolute value. And since n is greater than or equal to k, our n is positive, that is n is greater than 0. This is equal to what? 1 over root n. Since n is greater than or equal to k, and k is greater than 1 over epsilon squared. And so this means that this is less than what? 1 over the square root of 1 over epsilon squared, which is less than what? 1 over 1 over epsilon, and that is less than epsilon. The absolute value of an minus a is less than epsilon. That implies that what? 1 over square root of n minus 0 is less than epsilon, which is what we have proven, that the sequence 1 over square root of n converges to 0. It further implies that limit as n tends to infinity of the sequence 1 over root of n is equal to 0. And that is what we have been able to prove there. If you have benefited anything, if you have learned anything from this video, give it a thumbs up, like, and share with your colleagues. Have a beautiful day. Thank you, and God bless you. I see you in the next video.